Hello, ladies and gentlemen. Welcome. I'm sorry that I can't be with you today, but that doesn't mean we cannot still get a lot of learning done. So we will get started. This video will learn about types of chemical reactions. So while this video is playing, make sure you pause it at various points. That way you can jot down some of these notes. These notes will be very important, very helpful for later in class today when you do start to work on your types of reactions poster project. Make sure that you pay particular attention to when I start talking about the different pictures that I use to represent the different reactions, because what you are going to have to do is very similar. You're going to have to come up with pictures to represent the different patterns that exist for 4 of the 5 types of reactions. So let's get started. Let's start with what is a chemical reaction. A chemical reaction is any process that involves the rearrangement of atoms of a substance to form something new. So, the most basic method, or the most basic way that our chemical reaction will look, is we have 2 things that are added together with an arrow in the middle, and then they form 2 things that are added together. So we're going to focus on patterns today, so we will not worry about adding compounds or molecules into these. So what we need to know about this is that the reactants are on the left side. There's usually 2 of them, sometimes 1, and products are on the right side. Again, there can be 1 or 2 of them. So that's the notes we have to take. Reactants are on the left side of the arrow. The reactants, these are what will undergo the chemical change in the reaction, and the products, those are on the right side of the arrow. This is what's formed in the chemical reaction. Don't forget to pause if you need to. So the first type of reaction that we'll learn about is a single replacement reaction. Your definition for a single replacement reaction is a single replacement reaction. These can also be called as a displacement reaction. Is the type of chemical reaction where an element reacts with a compound and it takes the place of another element in that compound. So it sounds complex, but let's take a look at a pattern. So the pattern that will exist is AB plus C will yield AC plus B. The yield is the arrow sign. So let's take a look at this piece of paper. So on this piece of paper, I have that pattern listed. So typically what happens in this single replacement reaction is what we see here. So we know from our bonding unit that the first ion in a compound is usually positive. The second one is usually negative. So then what we see happen here is this would typically react with another positive ion, and then we see C and A switch places. So then when we look at the product side now, we see that A and C are bound together, and now B is separate. So if we were to re-look at our single replacement reactions, oh no, technical difficulties. Let me pause. Alright, so now we're back. Sorry, my picture wouldn't load. So what we see here in this picture, so we see that there's a couple that's dancing, and then there's a lone gentleman that is trying to butt in. So we see here that the lone gentleman is A in this reaction, and then the couple is BC. So we see here that A and B end up switching places. So this picture represents the pattern because we saw that the 2 gentlemen swapped places. A is now dancing with C, and B is now unfortunately alone. So let's move on to the next type of reaction, double replacement. So a double replacement reaction, these can be called double displacement reactions. It has another name, metathesis reaction. This is a type of reaction when the cations and anions, remember cations are positive, anions are negative, they switch between 2 reactants to form new products. So the pattern that we have to know for double replacement reactions is AB plus CD produces AD plus BC. So let's do the same thing. Let's take a look at double replacement reaction on this separate piece of paper. So again, same principle applies. The first ion is positive, the second ion is negative. So then we see CD happens the same thing. C is positive, D is negative. So now we need to figure out which ones switch places. So we know that positive and negatives have to be bonded together. So what I think about is, okay, we're going to swap the positives and the negatives. So we know that A and C, these are going to swap places. Swap places. That way, A will now be where C is, and it's bound to D on the product side. B will now be bound to C on the product side. They end up swapping places to make new compounds. Remember, in a reaction, we know chemical changes, something new has to form. So we have to combine these in a way where the positives and negatives will combine to form something new. So let's take a look at a picture example. So this one, we have some pigs and we have some penguins. The penguin is starting on the left side wearing a top hat. The pig is wearing glasses. So then what we end up see happening is the top hat and the glasses end up, the top hat and the glasses end up switching. So then on the product side, we have the penguin in glasses and the pig in a top hat. This is representing the pattern where the top hat and the glasses are the ions that are switching places. Next, we have synthesis reaction. So synthesis, this is where it starts to get a little bit easier. Single replacement, double replacement, those ones are the trickiest. So a synthesis reaction, this is a type of reaction in which multiple reactants combine to form one single new product. So the pattern that we see here is A plus B yields AB. So there's not a whole lot to say here other than A and B combine to form something new. So let's take a look at a picture. So in this picture we have a bird and a worm. Birds eat worms. So they combine and the bird is no longer hungry. It's full and it's burping because it just ate some food. After you eat a big meal, sometimes you burp. You can also see that his belly is sticking out to show that they are combined. So again, it's just two separate things that are combining into one new thing. Next, we have decomposition. So again, sorry for some technical difficulties. I guess we can already see my picture, but let's ignore it for now. So decomposition, or we can take a look at the picture. We can see that decomposition is now one thing that's breaking up into two. So we started with a forklift. It broke up into a fork and a monkey that's lifting weights. So it broke up into a fork and a lift. It's like a compound word breaking up into two separate things. So that's exactly what it is, a decomposition reaction, type of reaction in which one reactant yields two or more products. So the forklift turned into a fork and the lift. So the pattern that we need to know is AB breaks down, yields into A plus B. And the last type of reaction is combustion. So this is typically everyone's favorite. This is when stuff starts lighting on fire, it starts burning. We can think back to the candle lab. I know it's not as exciting, but we actually did a combustion reaction in the candle lab when we were learning what's released from that candle. So in a combustion reaction, you have a hydrocarbon and it reacts with oxygen to form carbon dioxide and water. So these ones typically are the easiest because they're the same every single time. You have a hydrocarbon reacting with oxygen and it forms carbon dioxide and water every single time. Remember when we lit that candle on fire, when we hold the beaker over the top, we were able to tell that water was being released from the flame as it collected on that beaker. So let's take a look at this combustion reaction. Let's focus on this word hydrocarbon. So kind of sounds like a big fancy word, but it's actually exactly what it sounds like. Hydro sounds like hydrogen. And then carbon is an element. It's hydrogen and carbon bound together. So your combustion reaction will be any amount of hydrogen and carbon bounded together, reacting with oxygen to form carbon dioxide and water. So that is actually all of the notes that we have to take today. I hope that at some points during the video you guys did pause and you were able to jot these down. These notes will be super helpful when you are looking at the type of reaction poster project that you have to work on. Essentially what you have to do in that project is take the patterns and come up with your own pictures to represent them. You are welcome to use computer generated images or you are welcome to draw them. It is your choice. So before I go, I do want to leave you with a joke. This is a joke that's from yours truly, Matt Reeves. He shared it with me today after his midterm. So what did one cannibalistic clown say to the other cannibalistic clown? You taste funny. You get it? Because clowns are funny. Well, I hope everyone has a great day. Enjoy working on that poster project, and I will see everyone when I return. If you have any questions, please make sure you write them down. That way, when I return, I can help you. I hope everyone has a wonderful day. Bye.